Dr. Phil Jackson, and it's all you.
Okay, I don't see that I have control yet of the screen or ability
You should be able to share.
Okay, here we go. Okay, so now in theory you can see my my slides.
We can see it.
Okay, I'm going to talk today about how to achieve superintelligence eventually with a natural language of thought. And let's see. Trying to get okay, let's see. So the first question, actually the topics I'm going to discuss are what is human level intelligence, and what would be human level AI? What are the major options for achieving human level AI and for understanding natural language? I'm going to talk about the Telemind approach that I advocate for achieving human level AI. Then I'll transition into talking about collective intelligence and superintelligence. And I'll go quickly through all my topics, and I should be able to finish in about 15 minutes.
Could you put the full screen?
Okay, let's see. Try to make this a full screen. How's that?
Your slideshow.
At this, is that better for you?
No, it's actually worse now.
Okay. Well, I apologize. I'll go back to the way it was, and I'll just go ahead and talk. So the first question is, what is human level intelligence? And defining this concept has been a challenge for AI researchers. Some people have suggested that human intelligence may not be a coherent concept that can be analyzed, even though we can see it in other human beings. A Turing test can help recognize human level AI if it's ever created, but the test doesn't define intelligence or indicate how we should design or implement or achieve it. Also, a Turing test focuses on recognizing human identical AI that's indistinguishable from humans, but it may be sufficient and even important to develop systems that are human-like and understandable, but not human identical. So for an approach different from the Turing test, I proposed that we define human level intelligence by identifying abilities that are achieved by humans, but are not yet achieved by any AI system. And I call these higher level mentalities. So they together are a qualitative difference that distinguishes human level AI from any current computer AI systems. They include natural language understanding with the same generality and flexibility that humans achieve, self-development, higher level learning, metacognition, imagination, artificial consciousness, and the other things in this list, but all with the same generality and effectiveness and efficiency that humans achieve. And I'll talk very briefly in this talk about higher level mentalities or higher level learning and artificial consciousness. Higher level learning includes learning by reflection and self-programming, reasoning about thoughts to develop new methods for thinking, learning about new domains by developing analogies and metaphors, learning that's supported by invention of languages and representations. And these topics have been studied in previous research, but not nearly to the same extent as people have focused on lower level forms of machine learning, like neural networks, for example. Artificial consciousness, first of all, I accept the objection that a system that's not aware of what it's doing and doesn't have some awareness of itself cannot have human level intelligence. So I adapt the axioms of being conscious that were proposed by Alexander Morton. And to claim a system achieves artificial consciousness, it should be able to demonstrate that it can observe itself in relation to the environment, observe its internal thoughts, have observations about time and potential futures, and have reflective observations. And to observe these things, it has to have representations of them and support processing those representations. Now, artificial consciousness does not imply that a system would have the human subjective experience of consciousness, so it avoids the so-called hard problem of consciousness. So what are the major options for achieving human level AI? Logically, there are three alternatives: purely symbolic approaches, neural network architectures, and hybrid systems. Now, you can argue theoretically that either purely symbolic or purely neural networks could be successful based on their generality. But hybrid systems could have some advantages. The two approaches could augment each other, and symbolic processing could support reasoning and representing context, sentential structures of sentences, and neural networks could support recognizing patterns that symbolic systems don't represent so well. So I advocate a class of hybrid architectures that I call the Telemind Architecture. The options for understanding natural language are parallel to those for human level AI. Again, you could have purely symbolic approaches, neural networks, or hybrid systems. And again, there are arguments in favor or support the generality of either symbolic or neural networks, but also reasons to favor hybrid systems. If we focus just on the symbolic approaches, there are two major approaches that are alternatives to discuss. The first is to treat natural language as external data, to translate natural language expressions into some simpler internal symbolic language like predicate calculus or conceptual graphs, and then to process those internal data structures within an AI system. And this has been the traditional approach for AI for many years, many decades. The second approach is to use natural language as a language of thought within an AI system. So what this means is that we would create internal symbolic data structures that represent natural language, sentences, and syntax and semantics. And we would process those internal symbolic data structures within an AI system. And we might use other symbolic languages to support doing that, for example, to support pattern matching or interpretation. But these natural language data structures would internally be the highest level representations of thought within an AI system. Now, and also you could combine this with neural networks also in a hybrid approach. There's no scientific consensus that this approach cannot work. It's just been an assumption over the decades that AI systems should only use formal logic languages or simpler languages for internal representations. But there does not appear to be any valid theoretical reason why you couldn't use natural language as a language of thought in an AI system. So the Telemind approach that I advocate recommends building systems with essentially three conceptual levels: a linguistic level at which you would have the natural language of thought being used for symbolic representation, an archetype level at which cognitive categories can be represented with a variety of different methods, and an associative level at which you could have deep neural networks. And there could be overlap between the three different levels. I think that all three of these levels are important for achieving human level AI and also for superintelligent AI. So to transition to talking about collective intelligence, it's natural and consistent to have an internal society of mind, collective intelligence at the linguistic level of an AI system. And you could have subagents within a Telemind system that are using natural language as the language of thought for internal communication. And this kind of society of mind is in a broader sense than Minsky described. It corresponds to a paper that Doyle wrote back in 1983. He talked about a multi-agent system using a language of thought, but he did not discuss a natural language of thought. And likewise, you could have one or more Telemind systems that are interacting with one or more human beings, and they could comprise a larger collective intelligence. So then the question is, what would be superintelligence? It's natural to think that AI could improve itself and that this could lead to runaway increases in intelligence beyond the human level. This idea has been discussed for many decades. Turing and von Neumann even suggested it back in the 50s. And there are several ways that an AI system could improve itself relative to human intelligence. Speed of thought, information access, community of thought, as I've discussed, and nature of thought, as I'll talk about in a second. And all of these things could be combined recursively, compounded. And systems with these improvements you might describe as more and faster human level AI and call them weak superintelligence. If human level AI can be achieved, then it will be possible to create a weak superintelligence. And again, the Telemind approach could support doing that. The natural language of thought could be used to support communities of thought. By nature of thought improvements, I mean the ability for a human level AI to develop new concepts and new conceptual processes, new ways of solving problems, new ways of thinking. A natural language of thought could support doing that arguably better than any formal logical language. And new concepts and processes might be developed more rapidly by an AI system than humans could develop or understand them. That could lead to conceptual gulfs between AI systems and humans. Conceptual gulfs happen normally anyway between human minds. Scientists in one field may develop concepts that aren't understood by the average person or by scientists in other fields. And in some ways, we could think of the worldwide scientific community as super intelligent relative to any human individual. But conceptual gulfs between weak superintelligence and humans can be bridged because new concepts can be explained using a natural language of thought. So then the question arises whether it's possible to create a strong superintelligence that would be qualitatively superior to weak superintelligence, superior to having more and faster human level AI. And I discuss how this question could be answered yes or no in my 2019 book, but it depends on some limits and characteristics of human intelligence that we don't yet know. For example, we don't yet know for certain if human intelligence depends on quantum computation in the brain. Perhaps it's likely that the brain doesn't use quantum computation, but some scientists have proposed theories that it does. If human intelligence does not involve quantum computation, then Telemind systems, AI systems that do use quantum computation might in theory achieve a strong superintelligence that would be qualitatively superior to more and faster human level AI without quantum computation. But again, conceptual gulfs could still be bridged, at least partially, by using natural language to describe concepts. So achieving beneficial human level AI and superintelligence is going to be difficult. Defining ethical goals and creating systems that can distinguish right from wrong, it's not going to be easy, but it has to be done. And I think that the Telemind approach can help achieve beneficial human level AI and superintelligence faster and more safely than relying only on other methods. But there's much more work that needs to be done to achieve human level AI. And this is just a brief list of the various things that need to be done. And all these are discussed in more detail by my 2019 book. So since this conference is going to talk about open source later on today, I added this slide about semi-open source for the Telemind prototype. The software source code for the Telemind demonstration is available with an Apache license, which is essentially open source. It gives broad rights to use, modify, and redistribute the software. And the one-time cost to purchase the software is $20 for each purchaser. And for each of the first 5 people who accept the offer, it will include 20 minutes of my time to consult about TAL and Telemind using a person-to-person meeting on Zoom. But this offer is only available to the first 25 people in the USA who accept it and send payment by August 1st. So if you wish to accept the offer, just send email to me and we can do that offline. So that's basically the offer there. And the software is very open source, but it's also very rudimentary. It doesn't do anything except show how a Telemind architecture could work and support the scenarios that are described in my thesis and in my 2019 book. It's written in JScheme and Java. So I've basically finished my slides, and I'd be glad to try and answer any questions.
What's the title of your book?
The title of my book is Toward Human Level Artificial Intelligence.
Cool.
And actually, Towards Human Level Artificial Intelligence with a Natural Language of Thought is the full title, I believe.
Okay.
Well, I stand corrected. Here it is, Toward Human Level Artificial Intelligence, subtitle, Representation and Computation of Meaning and Natural Language. So it's basically, it's my thesis that I wrote back in 2014, but it has some additional material on future prospects for AI, superintelligence, and some of the things I've talked about in this in these slides.
Great. We'll put a link in the material we send out to everyone. Does anyone have any questions for Phil?